All right, boys, so this is our third video on balancing forces. In the first video, we dealt with this objective, explained that that force has magnitude and direction. So right there, you should have learned that any force, when you measure force, it should have an amount of newtons, which is its magnitude, and a direction that a magnitude acts in, which is its direction. Then from there, we used arrows to represent those forces, where the size of the arrow was the magnitude and the direction the arrow pointed in was the direction of the force. So you see this one built onto that one. Now this third objective, find the resultant force acting on an object, builds on these two objectives over here. All right, boys? So that's why we went through it in this order. For your notes, you'll be taking notes in this block over here, and these questions you're going to answer during this video, okay? So those will go over there, all right? Just so you know, and I think that's on the back of your page, if I'm not mistaken. Okay, so I'm going to read through the slide, and then I'm going to explain what it means, okay? Many forces act on an object at once. When the object is sitting still, we know that the forces acting on it add up to 0. If one person pushes with 30 newtons to the left and the other person pushes with 40 newtons to the right, the resultant force will be 10 newtons to the right. Okay, this is called resultant force. And the definition, which I will come back to in a moment, the resultant force is the overall force acting on an object. We calculate it by adding and subtracting the forces together. All right, so this objective here, this definition, resultant force is the overall force that is acting on an object. We calculate it by adding and subtracting the forces together. So let's go straight to the beginning. Many forces act on an object. So I'm going to start right in the beginning here. I'm going to draw down here. So let's say this is our object. Doesn't matter what it is. It can be a ball, it can be the earth, it doesn't matter. Let's say there's a force pushing it that way, and there's a force pulling it that way. Okay, so if each one of these forces are 10 newtons to the right, 10 newtons to the left, what we're going to do is this object is actually going to stay right there, okay, right on that line. It's never going to move, and the reason for that is this force over here is pulling with 10 newtons to the right, and this is 10 newtons to the left. So if you're pushing opposite each other and you're pushing with the exact same force, you're going to cancel each other out. And what's going to happen is we're going to have no force acting on it. So even though we have 10 newtons in each direction, the overall force, also known as the resultant force, is going to be 0 newtons, okay? So many forces act on an object. That's what I showed you there. I showed you 2 forces, just pushing and pulling, but there can be more than that. When the object is sitting still, we know that the forces acting on it add up to 0. Now, look at this. There are forces acting on an object. There are always forces acting on an object. So that ball I just drew, it had 10 newtons pushing in either direction. So we saw 2 forces acting on it. But it was standing still. It's standing still. So the overall effect when we add up all the forces has to be 0. So even though there are different forces acting on it, when we add them together, they add up to 0. So I'm going to draw another example just to show you what I mean. Here's an object that has the force of 10, let's say 15 newtons falling down, and then it has one person with a rope is pulling it up with 10 newtons, and another person is pushing from underneath with 5 newtons. Okay, so you see, oh, that's a terrible drawing. Let me just try and clean that up. Nope, not letting me erase it. Okay, anyway, so you can see, I'll use the highlighter. This force is 5 newtons, and this force is 10 newtons, and they're both pushing up together, all right? This force is the only one pulling down, and it's pulling down with 15 newtons. But what you'll see is they balance out. This 10 and 5 add up to 15, and this 15 is 15, so they cancel each other out. And this object right here in the middle will remain still. It won't move. Okay, let me try and erase all of this in one foul swoop. Nope, almost. Ta-da, there we go. All right, so I hope that makes a little bit of sense so far. So here's an example I used. If there's an object and somebody pushes with 30 newtons to the left, let's hope this screen isn't flipped when you watch it, but that's my left, 30 newtons to the left, and another person pushes with 40 newtons to the right, the resultant force will be 10 newtons to the right. Now what's happening here? Well, the 30 newtons is being cancelled out, is cancelling out 30 newtons of this side, which has a little bit left over, which becomes our 10 newtons. So what's happening, another way to put this, okay? The person on the right who's pushing with 40 newtons is pushing against somebody who's pushing with 30 newtons. So this guy has to he has to push harder than these 30 newtons. So for the first 30 newtons that this guy over here is pushing with, he has to overcome and cancel out the 30 newtons there. Then the object starts to move because there's another 10 newtons left over, and that is the resultant force. Okay. I don't think I can explain it any other way right now. So I'm going to go back to this definition. You can pause and write it down. Now, resultant force is the overall force that is acting on an object. We calculate it by adding or subtracting the forces together. Leave a little space when you write that definition down, because I want you to add a little more notes on it. Or I hope I didn't cut out there. I'm going to add a little bit more notes on it. For now, let's do some examples. So here's an example. Dave pushes with 20 newtons forward. That's Dave in front there. And Pablo pushes with 30 newtons forward. So this is 20, this is 30. What is the resultant force acting on the table? Pause, try and work it out, and then I'll come back to you. Okay, great. So you should have worked out the answer to be 50 newtons forward. Two things to notice. 50 is magnitude, forward is direction. Always include your units. So when I mark this, if you say 50, you will get it wrong. If you say 50 newtons, you'll get it half right. And if you say 50 newtons forward, you'll get it all right, okay? Because it matters that you say newtons, and it matters whenever possible to say the direction. Okay, here's another example. Carly is pushing with 50 newtons, and Sven is pushing with 30 newtons, okay? What is the resultant force? Please pause and give it a shot. All right, fantastic. So you should have found the resultant force to be 20 newtons to the right, because Carly is pushing to the right. Don't forget direction. Always add direction. All right, last one. So the ball hits the face with 100 newtons to the right. The face resists with 20 newtons to the left. What is the resultant force? Please pause the video and try and work it out. All right, fantastic. The answer will be 80 newtons to the right. Okay, so going that way, to the right, 80. All right, fantastic, boys. So you should be able to find the resulting force acting on an object. There will be some practice in the questions below. Good luck. Ask your teacher if you have any questions. Read through the article I provided you if you're still stuck. Good luck.